Welcome. Today we'll have a look at Leetcode 2554, maximum number of integers to choose from a range 1. So we're given an integer array band and two integers n and max sum. So we can choose any integer in the range 1 to n inclusive at most once. However, the integer we choose may not be a member of the band array. The sum of the chosen integers should not exceed max sum, and they'd like us to return the maximum number of integers. We can choose following the mentioned rules. Okay, so let's walk through this example and we'll see how to arrive at a reasonable solution. So they tell us we can loop through or have at our disposal any number between 1 and n. So we can loop through them. So let's loop from 1 to 5. And we'll check if the number is a member of band. If it is, continue, because that means we cannot use that number. Otherwise, we'll keep it running total and add that number to, or the current number to total. So total plus equals, we'll call it num. Now we'll check, is total bigger than max sum? If it is, we'll return the count of integers, or the count of integers we have included so far. So yeah, that's fine. Otherwise, we can increment our count. If we have gone through this loop, that means we can return the count, and that would be the answer. So let's walk through this first example here. So looping from 1 to 5, 1 is in the band, is a member of band, so we would continue, we wouldn't do anything. 2 would be the next number in this range. 2 is not a member of band, so we can continue on, and we can increment total. So we would keep a running track of total. So this would, it would initially be 0, but now it's 2 because we've added 2 to our total. Then we ask ourselves, is 2 bigger than 6? No, it is not. So we can continue. And that means, and then we increment increment count. So count initially is 0, but now it would be 1. Next number would be 3. 3 is not a member of band, so we continue. We add 3 to the total, which makes this 5. Is 5 bigger than 6? No, it is not. Therefore, we move on and we increment count. Count is now 2. Next number would be 4. 4 is not a member of band, so we avoid this. We add 4 to our total, which makes this 9. Is 9 bigger than 6? Yes, it is. So we return the count, which is 2. And that's basically the algorithm. You may be asking yourselves, well, what if we had instead have chosen 2 and 4? That would have gotten closer to the 6, because remember, the current total is 5. Because we chose 2 and 3. But notice though, the count of integers for 2 and 3 is 2. The count of integers for 2 and 4 is 2. So it doesn't matter how close you are to max sum, it just matters more about the count. So notice how the counts are exactly the same. So I just wanted to point that out. But it's a fair and it's a good, I think it's a good analytical question to ask ourselves. Okay, I think that's enough for us to get started. Now, one thing that'll help us here, if we check, when checking if number is a member of band, we'll convert band to a set. So let's do that. So S equals set band. And we'll initialize our counts here. So count equals 0. Count and total equal 0 and 0. Anything else? That's fine. So let's create our loop for I in range 1 to n plus 1. I'm using n plus 1 because they allow us to use any number, including n. So that's why I chose this as n plus 1. Now let's check if I is in band. If I in, now make sure to use the set here, not band. So we're using our set of band. If it is in S, then we continue. Otherwise, we add that to our total. And then we check if total is bigger than max sum, then we return count. Otherwise, we increment count. If we have gone through this loop, now we just return the count. And let's check it locally. Okay, looks good. For this problem, because it's somewhat simple and straightforward, there really isn't much room to improve. Meaning, like even the best time is 27 milliseconds, and we're at 51. I mean, I can submit it again, and it's just so the time difference are so small that it doesn't make a difference. And in fact, I think the best time is using the same exact technique. So it doesn't matter for this particular problem, because the overall complexity of the problem is somewhat straightforward and simple, where there isn't much allowance for like cleverness to improve our time. In any case, if you found this video enjoyable or helpful, please like or subscribe. Have a great day. Take care.